Okay, we are back. Yes, so we finished things about coastal, what you would call physiomorphologies, physiologies, physiography, various words, geographic words, but essentially we looked at erosional coasts, depositional coasts, primary coasts, secondary coasts, and so on. Now we will add a little bit of the coastal oceans, including some circulation characteristics and also marine pollution, which is obviously a big problem. So there is global warming, which is much more related to polluting the atmosphere with greenhouse gases. And in general, environmental change or global change also includes the pollution of soils, water, oceans, and so on. Okay, so we'll look at some of the human impacts on the oceans in terms of marine pollution. So the main chapter topics are a brief overview of the international laws that govern the oceans. Obviously, it covers 70% of the Earth's surface, and there are oceans way out there where nobody can see what you are doing, but there are rules and regulations that everybody is supposed to follow. You know what happens. Coastal waters, they are not the same everywhere, so we'll see something special about the Mediterranean, for example, as a feature that's quite unique. Coastal wetlands, what issues they are facing. We had a brief discussion about that in the last chapter, and how pollution has become a major issue for the ocean. So plastic, for example, that not only pollutes most of the land, but is also polluting most of the ocean. Okay, so coastal ocean has 95% of the world fisheries which occur within a 200-mile distance from the shorelines. What do you want to connect this with? Your previous concepts of ocean coastal upwelling. Remember, upwelling brings not only colder waters, but we'll see in the next in a chapter that's coming up that there are also nutrients that come up with it, and if you have enough light and nutrients, you're going to have photosynthesis, which means you start the food chain. So most of the fish tend to be within the coastlines. This is related to the exclusive economic zone and so on, part of the regulation system. And 95% of the ocean life mass, biomass, also lives in coastal waters. Okay, so we'll have to understand better what we are doing to the coastal ocean, in addition to understanding the circulation features, some of which we already looked at in terms of upwelling, favorable winds, and so on. Coastal oceans are also nursery grounds for many species, which means whatever comes in the rivers or as groundwater can affect life from the very beginning. Nursery means that's when they're being spawned, hatched, and growing into juveniles and adults, right? So land and ocean has this continuum, which is the coastal ocean. So carbon, nutrients, sediments, everything is going to transition through the coastal ocean to the open ocean. And we saw mangroves as a big part of that transition, for example. Of course, you also have coral reefs, salt marshes, wetlands, and so on. All of these are stressed by human beings. So this is a quick map of where the fish tend to be found, and you can see obviously they're all hugging the coast. These are the various numbers given, 1, 2, 3, and so on and so forth. Those are the rankings in terms of the catch levels for a particular period, or 2000 to 2004, where the data is used to rank these by very high biomass, very high fisheries, high, moderate, low, and very low. So you can see that there are these coastlines where the catch is very low. That is related not only to human activity, but also natural conditions which determine how much fisheries a coastal system supports. The difference between fisheries and agriculture, for example, is that you plow the land, you put fertilizers, and you can increase the yields by irrigation and so on. But in the open ocean, it's not that simple. It's a natural system, so you have to manage it by how much you catch. In general, the sustainable catch, for example, is determined not by how many seeds were put in and how much crop is expected and so on. So there is a disconnect in the way we think about fisheries and sustainable fisheries and how the system of fisheries actually works. Right? So this is just indicating that now we are changing the system by going into aquaculture production. This is just for 2002. So even countries like India and China are now massive aquaculture producers of shrimps and some fish. So India exports a lot of shrimp, for example, to the Western countries. And will aquaculture become a replacement for wild fisheries? Of course not, because there are many issues associated with growing a lot of fish in a small place. You will add fertilizers like you do for agriculture. That brings diseases like sea lice. It has oxygen problems. It has quality of fish problems and so on. So it is not straightforward to simply keep increasing aquaculture or fish farming and try to replace wild fisheries, but nonetheless they have to work together to solve this increasing demand for fisheries. Turns out that as incomes go up, people not only tend to consume more food, more calories and more meat, but also more fish, right? Fish is good for you. There are many cultures that eat a lot of fish, like the Japanese or many coastal states in India or many coastal countries around the world. It has good omega-3, good source of many nutrients and so on and so forth. So we need fisheries, we need fish. I love fish. Many people love fish. I love sushi. But we have to watch out for the impact of pollution on natural fisheries and how aquaculture can complement the shortfall or losses in fisheries.